All right, here so you can see three different types of circuits. The way I like to explain it is, if the current flows through one resistor, load, consumer, component, all mean the same thing, in order to get to the next one, so it has to flow through this resistor to get to this resistor to get to this resistor, that's the series circuit. If the flow makes a split somewhere and can go multiple directions, that's a parallel circuit. All right, so here it goes up and it can either go to this one or this one. So it's going to go to both. It's going to go to this one or this one. So that's a parallel. Parallel. If it has both, it's a series parallel. So here I'm going through one resistor, and then I have a Y, and then it's going to go through two resistors, and then back the arrow through one resistor. There could be many combinations for that. This is just a quick example to show you. So that would be called a series parallel. All right. So in order to calculate total resistance, for series it's real simple. You find all your resistances, R1, R2, R3, R just meaning resistance. So if this was 10, this was 8, and this was 6, it'd be 10 plus 8 plus 6. So the formula for series is R1 plus R2 plus R3. Put dot, dot, dot because it could be multiple. It could go on forever. You just add them together. Pretty simple. All right. Parallel is not as nice. Parallel has a formula that looks like this. 1 over R1 plus 1 over R2 plus 1 over R3, dot, dot, dot. You just keep on adding them up. So in this situation here, if resistor 1 was 10, resistor 2 was 10, resistor 3 was 10, it would look like this. You just replace all your R1, 2, 3, and 4 with 10s. The formula would be like that. So you do the bottom stuff first. 1 divided by 10 plus 1 divided by 10 plus 1 divided by 10. So that would be 0.1 plus 0.1 plus 0.1. So that's equals 0.3. So that's all the stuff on the bottom. So 1 over 0.3. So if you take your calculator out, 1 divided by 0.3 equals 3.33. So the total resistance in this circuit would be 3.33 ohms. So you can see the difference in series. You add them in parallel, you would have to use the big formula. Now, there are a couple little tricks. If you have only 2 resistors in a circuit that are equal, like 2 10s, it's going to be 5. It's always half of what it is. If I had 2 of them that were 100, it would be 50. All right, that's just a given. All right. If you have only 2, there's another little formula you can use that is just R1 times R2 over R1 plus R2. This only works for 2 resistors. Only works for 2 resistors. If you do any more, it won't work. And then to tackle a series parallel, you want to get all your parallels figured up first. So if these 2 were 10, it'd be the same as if you had 1 resistor here that was 5. All right? So you just add them now because you're in series. Not too bad. All right, we're not done. I like to prove the math works by showing technicians with a multimeter. So you can see this resistor here is 10.5-ish ohms or so. This one is 10, almost 10 even. This one's a little shy. They do have a variance on them of about 10%. I got them from Radio Shack. This one's showing 9.9. And this one's 10.1. So you remember that when you build them in series, you just add them up. So here's our 9.9 there, 10.1. This one would be a series circuit. So remember, it flows through one and then the other. This would be about 20 ohms. All right. See, I got 20.1. I add another 10 in series. I'm going to be around 30. All right. So the math works. That's series circuit. That's simple. You just add them up. But you remember parallel, we did the formula for parallel. 10, 10, 10. It ended up being a 3.3 or so. So let's build parallel. Shabby looking parallel. Alright, so the current's going to come in through here, and then it has three ways to split, so it's parallel. And by the time it comes out the other end, the resistance will be, it's showing 3.5, 3.4. So the math works. Oh, 3.3. I like it. Perfect.